is our poster presentation for Annihilator Chem. The team lead is Bryce Haddon. We have Emma Julius, Chris May Sepulveda, Mo Karufa, Asha Madugal, and our mentor is Dr. Thomas Koch, with our supporters being Parker Sipes and Sam Vandesandy. For our project, we were tasked with building a 3-in-1 meter that measures pH, salinity, and ORP and can be calibrated depending on the desired parameter. The main component will be the Arduino Wi-Fi Rev 3, which has the ability to connect to Wi-Fi and give real-time measurements and alert the user with live data. It will also consist of various probes and power sources that will be discussed in detail in further slides.
Okay, so over here we have our specifications. Our main focus is to have the meter to be a maximum of $250 and for the meter to be able to display the desired parameters after being calibrated, and also for the meter to be as compact and easily accessible as possible while being able to fit on the company's units.
This design is a simple box-shaped device. It is separated into two parts. The front panel has cutouts for the LCD screen and 5 buttons. The back panel has 3 holes for the probe BNC connectors. The back of the device has small sections in place for mounting.
Our main component of the meter will be the Arduino Wi-Fi Rev 3. It'll have an input voltage of 12 volts and will give out 3.5 to 5 volts per probe. It'll also connect to a server in order to give real-time data measurements for users from the given probes.
Here we have the probe selection. We decided to go with 3 individual probes to test pH, salinity, and ORP. We chose to keep them individual to keep costs down and for easier maintenance. The response time is 2 minutes maximum and can be operated on 3.5 to 5 volts.
Here we have the flowchart that shows the general path that the code will go through. It sets up the functions and connects to the Wi-Fi and then enters the recurring state. It takes the measurements from each probe and stores it while displaying the desired output to the screen. Then it checks if the value is below the threshold, sends an alert, and re-enters the recurring state.
So over here we have our bill of materials displaying the components that we need to buy in order to build our meter. As of right now, our meter is at $177 and it might go up a little in the future. However, our main objective is to keep it under $250.
Our future plans include purchasing orders and testing. We will finish the code and run it through Arduino. We will start doing basic connections for the probes and LCD screen for testing. Next, the casing will be 3D printed. Lastly, we will work on building a server to upload data and possibly investigate a battery-powered meter.